Today, from section 3.3, we are going to talk about an example related to derivatives. The relationship between the quantity of antibiotic left and times is modeled by function Q of t. Now let's dig in. Part A is asking for the instantaneous rate of change. Based on the knowledge we acquire from the text, we know that asking for instantaneous rate of change basically means asking for the first derivative of the original function. We have already learned the theorem 3.10. Which is derivative of e to the power of kx equals to k times e to the power of kx for real number k. Thus, we have d over dt times q of t is equal to negative 0.0693 times 20 times e to the power of negative 0.0693 times t, which is equal to negative 1.386 times e to the power of negative 0.0693 times t finally, and this is the answer of the question A. Part B is asking the rate of change of the amount of antibiotic when t equals to 0 and 2. So we can just plug the value of t in the first derivative of q of t we got from part A. For t equals 0, we have negative 1.386 times e to the power of negative 0.0693 times 0. So finally equal to negative 1.386. And do not forget the unit is mg per hour. Then we do the same for equals to 2. So d over dt times q of t is equal to negative 1.386 times e to the power of negative 0.0693 times 2. Then we get the final answer, which is linear to negative 1.207 mg per hour by rounding answer to 3 decimal places. The last question requires us to evaluate and interpret the value of q of t and the derivative of q of t when t approaches to infinity. We know the limit of q of t is equal to 20 over e to the power of 0.0693 t. When t is approaching to infinity, the denominator becomes infinitely large, which makes the whole fraction infinitely approach 0, so the answer is equal to 0. Same as the derivative of q of t, we have negative 1.386 over e to the power of 0.0693 t, and because t is approaching to infinity, the denominator becomes infinitely large, which makes the whole fraction approach 0 again, so the answer is 0. To sum up, when t approaches to positive infinity, none of the drug would remain in the bloodstream, and when t approaches to infinity, the rate at which the body excretes the drug goes to 0 over time. Here we have solved all 3 problems step by step. If you have any questions, please do not hesitate to contact me. Thank you for your time watching this video.